discuss before we even start anything. So these are my props. Sometimes I use my props. Number one is a piecewise defined function. So please take notes. I'm going to try to be as slow as possible so you can ask questions. A piecewise defined function, as an example, is the tax code or tax law. How come? Okay, I'm just going to make up some numbers. Let's say for someone who with an income from 0 to 30,000, that person, let's say, pays 5%. I'm making up numbers. Don't rely on these. It's just an example. For someone who makes between not 30,000 but 30,001, and I don't know, 50,000, let's say that person pays 6%, and so on and so forth. This is an example of a piecewise defined function. Okay? Another example would be, which probably is not relevant anymore, is something like paying for the phone bill. Assuming I talk between 0 and 100 or 1,000 minutes, let's say, pay $21. Making numbers up, of course. Between 1,000 and 2,000 minutes, of course, I have, I don't know, $31, and so on and so forth. So this is another example of a piecewise defined function. In other words, a function that is defined in pieces. For these x values, this is the function. For these x values, this is the function, and so on and so forth. So let's make one up, a simple one, with two branches or pieces. Can anyone give us two functions? Anyone? Any two functions?
X squared minus 1.
For any x you want, whatever x you want.
3.
For x less than or equal to?
Any number?
Yep.
5.
Excellent. Well, let's say that's greater than 5.
Yep.
Give me another function.
3x plus 4.
3x plus 4. Perfect. Excellent. So can anyone tell us what type of function is this and what type of function is this?
The top one's quadratic.
Excellent. Who said that?
I did.
Good. And this one?
Can I also do this one?
Please.
Linear.
So I'm hoping that no one has difficulties identifying this as quadratic and this as linear. Thank you. Okay. So every time we're asked to graph a function, of course, a function, we need to go through the following steps. Number one is domain. Always. Number two, x and y intercepts. Of course, if they exist. Number three, table of ordered pairs. Used to graph the function. Number four, of course, if the function has asymptotes, has other things, it's a different story, but these are the main steps. And number four, range. So we can add on depending on the function, but For a piecewise defined function, that's what we need. Now, let's go back to the function and identify the interval. There is an interval here. Can anyone tell us what interval is this? And how do I write the interval notation for this? Anyone? How do we write?
Bracket and then 5, comma, or sorry, no, it's negative infinity, 5.
Excellent. Thank you very much. The bracket signifies the equal symbol. Excellent. Thank you, Quinn. Good. And this one?
It'd be parentheses 5 and then infinity.
Excellent. Great.
Parentheses.
Thank you. So this parenthesis signifies no equal symbol. Good. I'm still working on the domain. Now, this piece is for this function. This piece is for this function. But I don't care. What is the domain of this function?
Infinity to infinity.
Exactly. Nothing is missing. This one stops at 5. 5 is there. This one doesn't have 5, but I don't care. It has 5 is in here, right? So that's my next step. Identifying the domain, and now the table. I didn't forget about the x and y intercepts. I'll get there in a minute. Please, I'm not against vertical tables. They are useless. I accept them though. But please, this is the x, this is the real line. Real line is not vertical. The real line is horizontal. So again, I accept other ways. If you know a different way and you like it, just look at mine and adopt it if it's better for you. If it's not, I understand. Okay, so the very first thing that I need to put in my table is 0, of course. And the second one, which is extremely important, is 5. Notice that everything has to be in the correct ascending order. Okay. Next step. I notice that there is a bracket facing this way under 5 and a parenthesis facing this way. Exactly under 5, not here or here. Exactly under 5, I will put those two symbols touching each other. The bracket to the left and the parenthesis to the right. In the next step, I'm going to take my first piece, negative infinity to 5, and right on top of it, x squared minus 1. Then, in the second piece, between 5 and infinity, and right on top of it, 3x plus 4. So I don't have to go back to the previous page. And not just that, just to make sure that I also use the correct function. Okay, so I will plug in, because I know how to graph this, and I hope that by now everyone does. So remember, x squared is something like this. This is the x squared. From transformations or from basic functions, we should know this. And minus 1 pulls the graph down 1. So this will be x squared minus 1. We do not care. This was just a review, a quick review. This is not the graph of what we are doing here. But this is, if I just had x squared minus 1, this is a refresher. This is the quadratic function x squared, and this brings down, it's a vertical shift of 1 unit down of x squared minus 1. Okay, so normally I should determine 3 points for such a function. When I plug in 0, I get -1. I know from my previous knowledge that it will cross at -1. -1 squared is 1, minus 1 is 0. And it will also cross at 1, because 1 minus 1 is 0. So I always look for the x and y intercepts, if they exist. Okay, so now I will plug in 5. 25 minus 1 is 24, and I will write the answer right here inside the bracket. Why am I doing this? It's because this will be a full point. Full point. Now, when I plug in 5 in this function, you will say, no, you can't. You cannot plug in 5 here when it's equal to, and 5 here when it's not equal to. You cannot do that. Okay, but if you say that, then you will have to plug in 5.000001. Because the next step does not start at 6. Because if you start at 6, then you are omitting infinitely many numbers between 5 and 6. So instead of plugging such a number in, I'm going to plug in 5 times 3 is 15 plus 4 is 19. Write the number inside. And remember that this will be an open point. So when I said this equal to 0 to find x and y intercepts, it's -4/3, but -4/3 is on this side, so there is no x-intercept, but I need another point because it's linear. I'm going to say when x is 6, 18 plus 4, 22. So what I accomplished so far is the domain and the table, and I also have the x and y intercepts, and the range will be determined after I graph the function, not before. So I'm ready now. No one stopped me, so I'm assuming you're okay. Any questions? Anyone? Okay. -1, 0. Zero, -1. 1, 0. 2, 3, 4, 5. Since this is a big number, I'm just going to say here 10, 20, 30. So I'm going to put this number in here, or this ordered pair in here. Yes, it's not going to look right because the quadratic function cannot look like this, but because it's such a big number, I have to truncate. I have to do something here, right? So these are all full points. I used green. I'm going to graph. This is quadratic. I'm going to stretch it a little bit. It's not going to look as a quadratic because I had to change the scale. I'm done with this color because the next one has to start where this one ends. So 519, it's going to be an open point. And then 622 somewhere here. And this is the linear piece. Why I use two colors, not a big deal, but I want to make sure you understand that you cannot ever graph something like this. This is not a function. The green piece is between -infinity and 5. The orange piece is between 5 and infinity. 5 and infinity. -infinity and 5, green. 5 and infinity, orange. Something like this is not a function. Now, finally, we have the range. Remember how we determine the range? From the lowest y value, where the function exists, I caught it, yes, I caught it, yes, 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 yes. So then the range of this function is -1 to infinity. From the lowest y value till the largest y value. Any questions on this problem? Any doubts? Okay, again, there are multiple examples in the previous videos. Do we need another, or are we okay with this? Do we understand these bracket and parenthesis? Is that a yes? Is that a no? Anyone wants to say?